All right, out of a request, we are going to do two other power series and determine their radius and interval of convergence. So I have chosen, let's see, so this one is in the scheme of the last problems that we did. Okay, so this will be number 5 from that section. All right, so the summation n equals 0 to infinity of n x to the n over n plus 2. Okay, so this power series, we want to determine if and when it converges. So for this one, I think I would probably use the ratio test. So I choose the ratio test because I don't know how to take the square root of, I could use the root test, either one will work, but I'm just going to use the ratio test. Okay, so A sub n an is equal to n x to the n divided by n plus 2, and an plus 1 is going to be n plus 1 x to the n plus 1 divided by n plus 2 plus 1, which will be n plus 3. Okay, so the ratio test says that when I compute rho, which is the limit as n approaches infinity of the absolute value of an plus 1 over an, if this is less than 1, then this series will converge. Okay, so I'm going to compute rho equal to the limit as n approaches infinity of the absolute value. So an is going to be n plus 1, x to the n plus 1 divided by n plus 3. When I divide by an, since it is a fraction, I'm going to multiply by the reciprocal. So I'm going to get n plus 2 over nx to the n. So now I want to simplify this. So this is the limit as n approaches infinity. So now the n plus 1 over the n plus 3 and the n plus 2 and the n, I can put them together. So I have n plus 1, n plus 2 divided by n plus 3 times n, and all of those are positive. Now, what happens with the x's? Well, the x, I have x to the n in the numerator, and x to the n plus 1 in the numerator, x to the n in the denominator. So that just becomes the absolute value of x to the first power. Okay, so now I need to do this limit, and I don't know if you can already see that all of this literally just goes to 1. I don't know if you can see that. That is the limit as n approaches infinity. If I divide everything in the numerator by n, I'm going to get n over n, that's 1 plus 1 over n. Then I'm going to get n over n, that's 1 plus 2 over n. And in the denominator, I'm going to get n over n, that's 1 plus 3 over n. Nope, 3 over n. And then I'm going to get n over n, which is just 1. And this is still times the absolute value of x. And this is actually just equal to the absolute value of x. So For convergence, I have to force it to be less than 1. So I get there that my radius of convergence, R, turns out to be 1, and my interval of convergence is -1 less than x less than +1. And then I need to check my endpoints. So I need to check 1 and -1.
Wait, I'm sorry. How did you find 1 for R?
Oh, because whenever you get the absolute value of x is always absolute value of x minus a. Whatever you get at the end, that is R, whatever that number comes out to be. So if I had gotten the absolute value of x over 3 was less than 1, then I would have said the absolute value of x is less than 3, and I would have said that R is equal to 3.
Oh, okay. Thank you.
So, yeah. And so if it happens to be one that's not about 0, if it's one about a different number, then you have to make sure you have, so whatever you get at the end from your test, that's what you use. So I'm forcing it to be less than 1, so I get radius 1. Had I had something different, I would still force it to be less than 1 and then solve for it. So now I need to check the endpoints. Because if you remember the ratio tests, when the row is actually equal to 1, it's inconclusive. So it doesn't tell me anything. So I still have to find it. So when I check my endpoints, I get if x is equal to -1, my series becomes the summation n equals 0 to infinity of n over n plus 2 times -1 to the n. Would be n over n plus 2 times -1 to the n. And so this is an alternating series. But it's going to fail the alternating series test. So it fails to have the conditions for the alternating series test, because anybody can tell me right away why this is going to fail? Can you see it? It fails condition 3. Because un here is n over n plus 2, and that goes to 1, which is not 0. So it fails condition 3. So by alternating series test, I still don't know. And I can tell you if I use the ratio or the root test, I'm still not going to know. And so the jury's still out for -1. So I can't say it converges on -1 because I just don't know. If I check x equals n, if x is equal to 1. So basically all of this is inconclusive. I just don't know. I'm not going to fill it in because it's inconclusive. I don't know. But if I check x equal to 1, I get the summation n equals 1 to infinity of n over n plus 2. And by golly, that thing right there, an is n over n plus 2. And we already said that goes to 1, which is not 0. So this fails. So for by the nth test of convergence, nth term test of convergence, the series diverges. So I'm going to stick with my original answer. My radius is 1, and my interval of convergence is -1 to 1, is my interval of convergence. I'm not going to adjust it because it's inconclusive at one place, so I don't know. Any other place, it definitely diverges. Okay, so that is 1. Any questions about that?
No, thank you.
Okay, do you want another one or you're good?
I think I'm good.
All
Thank
right,
you.
yay, let's go on to the next stuff. Okay, so I'm going to stop this video because this was a little piece, a little additional power series piece. So let's stop that.